purpose of this video is to go over scalars and vectors. Our objectives are, by the end of this video, you should be able to state what a scalar is, state what a vector is, and give examples of scalars and vectors. Scalar and vector quantities. The definition of a scalar is a measurement with magnitude or size. If you imagine during an earthquake, when they say the magnitude of the earthquake was a 7.2, they're describing it from the Richter scale. But the 7.2 is the size or the magnitude of the earthquake. When you deal with a vector, it is a measurement that has not only the magnitude or the size, but it also has a direction as well. For instance, if you push or pull a car, you have a certain direction that you are pushing or pulling a car. That would describe a vector. So we'll go over a couple of quantities and see which ones are scalars and which ones are vectors. So some examples, we have distance, position change, speed, velocity, acceleration, mass, weight, force, temperature, and time. There are quite a few other vector quantities and scalar quantities that we're not going over today, such as momentum would be another one. But we're just going over a couple of the ones that we'll see here in this first quarter. When we take a look at these, we have the answers as either scalar or vector. Distance is considered scalar because when we talk about distance, we're looking at how far someone has traveled. You don't say, well, I traveled 18 miles west. Well, you could, but that would be your position change. The purpose of the distance, though, is just simply to describe how far you've gone. And because of that, we really don't worry about the positive or negative, and so therefore it is a scalar vector, or scalar quantity. In terms of position change, though, that is a vector quantity because you want to know how far you've moved from your previous position, as well as what direction you've moved. So that would be a vector. When we deal with speed, you notice on your speedometer on a car that it has a positive velocity, or a positive speed to it. And so we consider that to be a scalar quantity. The speed just simply tells us how quickly we are moving. So because of that, it's going to be a positive number. When we deal with velocity, velocity is basically the change in position over the amount of time that it's taken to change that position. So velocity is a vector quantity, just as position change was a vector quantity. The velocity, well, tells us what direction we're traveling, not only the speed, but also the direction. And that is basically one of the premises of velocity, is its speed in a given direction. The next one is acceleration, and that is a vector quantity because acceleration is defined as the change in velocity over the amount of time taken to change that velocity. So therefore, acceleration is a vector quantity as well. Are we going to have a positive acceleration and negative acceleration? Are we accelerating to the north, to the south? So therefore, since we have that direction involved, it is a vector quantity. Next up is mass, and mass is a scalar quantity because when we take a look at how much matter an object takes up, we're not really interested in the direction, we just want to know how much mass it has. However, when we talk about weight, weight is basically a gravitational interaction between two objects, and so because of it, we have direction. In your case, your weight is measured against the force of the earth pulling on you. You're also pulling on the earth. We put a scale between you and the earth, and we measure basically that interaction, and that is considered your weight. The next one is a force, as we've already talked about, which is a push or a pull, and so that is a vector quantity because we talk about how much we're pushing, but also what direction we're pushing. Now the last two, temperature and time, you might be able to say, well, we can go forward in time and we can look back in time, as well as temperature. We can have a positive temperature, it's 48 degrees Fahrenheit out, and during the winter it's -3 degrees Fahrenheit. But the condition with temperature and time is that they're considered scalar quantities because they don't really have a direction involved with them. So for instance, you wouldn't be saying it's 18 degrees Fahrenheit north. That doesn't make sense. So therefore, temperature is considered to be a scalar quantity as well as time. Between everything that we've seen here, quick definitions between scalar and vector and some vector quantities and scalar quantity examples. Hopefully we've been able to accomplish the objectives at the very beginning of this video.